Hello and welcome to today's webinar, Mainframe Virtual Tape, Complex Migration and Management Made Easy with the ZVT and ZVT Control Center, brought to you by Optica Technologies. My name is Whitney Lingefelter, and on behalf of Share Headquarters, I'd like to thank you for joining us today. Share is pleased to continue our webinar programming with this informative and educational event. Please note that presentation slides and recordings will be available post-webcast at www.share.org. Today's presenters are Sean Seitz, VP Technical Services, Optica Technologies, and Steve Pryor, Senior Software Developer, DTS Software. Sean is responsible for technical sales, services delivery, and product support worldwide. He brings 30 years of mainframe industry experience in technical field management, consulting services management, and business development. Prior to joining Optica, Sean worked for Mixed Data Corporation, where he fulfilled various professional services, sales, and services management roles, as well as for Fujitsu Technology Solutions and Amdahl Corporation. Steve is a senior software designer at DTS Software, Inc., with over 30 years of experience in the design, development, and support of DOS storage systems. He has spoken at numerous Share and other industry conferences and has taught on storage topics both domestically and internationally. He is also a semi-professional actor. We encourage you to submit questions throughout the event via the Q&A box on your webinar toolbar. Your questions will be addressed in the order that they are submitted. I would like to now turn the web over to today's presenter. Please go ahead, Sean.
Thank you, Whitney. Very much appreciate your hospitality today, and thanks to Share as well for hosting the webcast. And thanks most of all to the attendees today. I know everyone is busy, time is valuable, and we appreciate you joining us here for about an hour. We look forward to hopefully teaching you something new and giving you some new insights around our ZVT virtual tape solution, as well as the DTS management interface to the ZVT, known as ZVT Control Center. So thank you very much again for joining us. By way of an agenda today, I will be quickly giving you a highlight of the companies and the company background, both Optica and DTS, to give you a quick understanding. And then we're going to talk about why did we actually get into the virtual tape space. We're going to talk a little bit about the market overall for virtual tape and how we fit. Then, of course, we're going to overview our ZVT family of virtual tape solutions. Then we're going to talk about a customer project example, actually a very recent customer that was able to take advantage of the ZVT and the ZVT Control Center from DTS. So the combined solution added value to a customer, and we're going to highlight that for you. And then we're going to pause briefly for a poll question. We kind of like to get some audience participation, so about midway through, we'll pause, we'll ask a poll question. It'll pop up on your screens, and we ask for your participation. Give you about 20 or 30 seconds to respond to the multiple choice question answers, I should say. And then we'll show you the results, and it might be interesting to see kind of from the audience what the results look like. And then I'm going to turn it over to Steve Pryor from DTS, and Steve is going to highlight the ZVT Control Center, also known as ZCC. He's going to do a little bit of demonstration as well, so he's going to kind of flip between charts and an actual live product demonstration to kind of demonstrate the value around this product, which is a set of tools that enhance the control of the ZVT product. So it's an exciting partnership we have. We're excited to have DTS and Steve joining us today to talk about the ZCC technology. And then at the end, we'll have some time for questions. So as Whitney indicated, feel free to submit your questions at any time through the presentation. And if it's a relevant question to the content we're at, we'll stop, actually pause and answer the question midstream, or otherwise we'll wait perhaps till the end and answer questions at the end. But either way, we will get your questions addressed. Okay. So in terms of the companies, we're actually quite similar to each other, and it's an interesting phenomenon that we have similar heritage between Optica and DTS. First, for Optica, we've been around for more than 50 years. We've been around a long time. In the last 25 years of our existence, we've actually focused on mainframe solutions exclusively. Actually got started in bus and tag switching and moved on to protocol conversion. So it was in the late 90s, we developed an SCON to bus and tag converter solution for IBM mainframe users who wanted to migrate forward on their mainframe platform but still needed to manage parallel devices. Obviously, IBM had a solution as well known as 9034, but IBM decided to exit that business. So it was 2002 when IBM contracted with Optica. They exited the manufacturing business of their 9034. And they contracted with us to be the exclusive provider of SCON to bus and tag converters. We sold thousands of those products, and believe it or not, we still receive requests for that product today. We have many of these products in existence still running. And I would say, pardon me, if you've been a mainframe user for a couple of decades, chances are very high that you've actually used our protocol converter products. So it was really that relationship that drew us very close with the mainframe division of IBM, and we remain a very strategic partner to the Z Systems Group in Poughkeepsie. So we value that relationship, and they played a part in us entering the virtual tape space, which I'll address as well. So ultimately, we have a very deep mainframe heritage. We have a lot of mainframe skills. Obviously, world-class knowledge of protocols, having done the protocol conversion solutions. The follow-on to the SCON to bus and tag converter, by the way, is a FICON to SCON converter. When IBM decided to discontinue SCON on the mainframe, they obviously approached us as their exclusive provider and asked us to develop the FICON to SCON version. We did so, and that product's been available for about 14 years at this point, and it's known as Prism. So you may be familiar with the Prism solution that takes FICON to SCON. So again, a critical piece to IBM and the Z Systems division and their customers. And then ultimately, we're here to talk about ZVT, our virtual tape family of products. Those were announced in January of 2015, and we'll look forward to getting into a little more detail around ZVT for you. Relative to DTS software, they've been around for almost 27 years. They're a leading storage management technology company. They sell their products globally and also have thousands of data center deployments around the world. They share our commitment to high reliability, quality, and especially customer satisfaction, which is a very key tenet for both companies. They announced the ZVT Control Center, again known as VCC, in February of 2016, so a little over a year ago. But the product wasn't brand new in the sense that it was based on other products that they had developed for other virtual tape solutions. Specifically, they had developed a Control Center product for the BusTech MDL previously, and also for the EMC DLM. So they're very much experts in this arena. They were able to port a lot of their stable existing technology into a set of tools that we now call the ZCC, that again enhances the control, administration, management, and monitoring of the ZVT product. So we're proud to be partnered with DTS, and again, a very similar company to Optica in that we both share a common commitment to quality and customer satisfaction. Okay, so why did we enter the mainframe virtual tape arena, right? There's already a lot of players involved. Frankly, there's several reasons. So after we established ourselves in the mainframe connectivity space with our products over a 25-year period, you know, there were several key reasons why we decided to get into virtual tape. First was we had developed extremely high tape expertise. In developing all these connectivity products we had over the years, we connected primarily to tape products, tape, physical tape, and products that emulated physical tape. So we developed over time a very deep expertise around tape operations, tape emulation, because we had to develop tape emulators for our lab, for other products. So it was a very logical extension. We almost had a virtual tape solution developed based on the emulation we've created over time. So it was the technology foundation was present. It was already there. Further, and I'm going to talk a little bit more about this in a minute, there was a big opportunity to address a segment of the mainframe ecosystem with a product that is sensibly priced, easy to use, easy to manage, and comes with excellent quality and excellent quality support, customer support. So we'll talk a little bit more about that in a second. But the third reason we entered was because of IBM's encouragement. I mentioned this strategic partnership with the Z division. They actually encouraged us to enter the space. Even though IBM Tucson offers a very good product in the DTS arena, they encouraged us to get in because of the mainframe customer. They recognize the mainframe customer requires a product that covers more of the market than what the IBM solution covered in others. So we actually had full support from the Z division to enter the space because they recognize the value to the customer. Those are the main reasons why we got into the market. The market is actually not very big by terms of the mainframe market. $600 million market annually is not gigantic, especially for what I call the big three players in this arena. It's a slow-growing market, but IBM, Oracle, and Dell EMC all have excellent products in the virtual tape space, but they tend to focus on the top end of the market. The very top of the enterprise market is where the focus is for those products. They're very complex to use, and they have a price tag to match that. Again, excellent products, but they tend to address the very high end of the market very well. We view that the rest of the market is underserved a bit for that reason. Underserved from the perspective of being able to migrate to a virtual tape solution that is not going to kill the pocketbook. It's going to be quality-based, easy to implement, easy to use, seamless, compatible, etc. So that's why we entered, and that's what we bring to the market. There's a couple other players, of course, below the big three that play in the same space we do, all the way up to the mid-market and above, into the enterprise space. But we view this as a key fit for the ZVT solution that we're going to talk more about. Okay. All right, so I wanted to give you a quick overview of the family of products that we brought to market in the virtual tape arena. So if we kind of move left to right, this is low end to high end, so to speak. And on the left side is the product that we call the ZVT 3000i. Now the 3000i is entry level from the perspective that it is an all-in-one solution. It comes with onboard storage, so you will not be connecting to back-end fiber channel or NFS-based storage. It's a self-contained virtual tape appliance, so onboard storage. So it's a perfect solution to replace, we found, physical 3490 tape or 3590 tape that have gone end of life. So by way of some specs here, this product comes with 2 FICON interfaces to the mainframe. You can also get SCON, by the way. We still offer SCON because we have customers in Japan, frankly, that still require it. Japan tends to be several years behind the U.S. and European markets, so there is still demand for SCON connectivity to the mainframe, so we offer both. We offer FICON and SCON. In terms of the number of virtual tape drives that are supported, the 3000i supports 8 as a standard. Relative to more than that, we can support actually more than that. We have customers that are running 16, for example, on the 3000i, and we can provide that on an RPQ basis. Okay? The 3000i has 4 terabytes of RAID 5 storage on board, and it comes essentially pre-configured. So it's really as close to plug and play for virtual tape as you can get. Okay? And then moving to the center here, the 5000 Flex is really what I would consider our flagship solution, in that it is the most popular model. The unique part about this product is that we do not define a limited set of storage vendors that you can put, or I should say storage products you can put behind it as your storage repository. You can literally attach any NFS storage or any fiber channel attached storage. So if you have an investment on your open systems side of your data center in a particular brand of storage and there's extra storage available that you could dedicate to the mainframe virtual tape application, you can do it. Okay, so the flexibility of this product is what is unique about it. I'm not sure there's another vendor actually in the virtual tape arena that allows you to literally attach to any NFS or fiber channel storage. So this has been a very popular choice for our customers so far, and it allows them to leverage existing investments. This product also offers FICON interfaces or SCON interfaces to the mainframe. And you can license up to 256 virtual tape drives per appliance. That gives us the ability to scale the requirement. We can price the solution starting at 16 virtual tape drives all the way up to 256 in a single appliance. So we can customize the virtual tape license to your requirement, the size of your environment. Okay, this product comes standard with 1 gigabit Ethernet connectivity to back-end storage. Also available with 10 gigabit Ethernet connectivity. Fiber channel connectivity to storage is also available, as I mentioned. All right, and we of course support all the advanced storage features, dedupe, replication, encryption, and those features are resident on the back-end storage. So the ZVT appliance, virtual tape engine will support those features, but those features are resident in the storage. Okay, and then of course we support multi-node for resiliency and high availability applications. Okay, moving all the way to the right is our 5000 INAS, and this is essentially the same virtual tape engine. It is the same virtual tape engine as the 5000 Flex and the 3000i, but it comes integrated with NFS storage. So if you're looking for an integrated solution that includes the NFS storage, it's the 5000 INAS that's for you. So we can scale this from 8 terabytes of storage all the way to 1 petabyte in a single frame or on a single floor tile. Okay, from a raw storage perspective. And then, of course, this supports all the advanced features as well, dedupe, replication, encryption, etc. All right, so we have an offering here that we think that matches just about any requirement that you may have. Okay, a few more details. I wanted to mention again that, you know, the virtual tape engine or the appliance that you're looking at here on the screen is the same. It's common across all models. So it's the same appliance essentially for the 3000i, the 5000 Flex, and the 5000 INAS. So these are really common specifications and features. I mentioned the mainframe connectivity, SCON or FICON. In terms of tape drives license support, again, this allows us to match the price point of the solution to your actual need. You don't have to take 256 virtual tape drives if you only have a requirement for 16 or 32. So we can license the product and quote it based on these increments, and that'll match, better match the price point to your requirement or the size of your environment. As far as operating systems support, we support all IBM operating systems, COS, VSE, VM. All of those are supported on a standard basis. So there's no RPQ required for VM, VSE. We support all of those plug and play. Okay. And then storage connectivity, so the back-end storage connectivity for the Flex model, for example, standard is 1 gig Ethernet. Optionally, you can have 10 gig Ethernet connectivity or 8 gig fiber channel. And then, of course, the 3000i does not have back-end storage, as I mentioned, as internal RAID 5 storage. 4 terabytes are included with the 3000i. Okay, and then when you're implementing the product, it emulates 3490 or 3590. We have customers doing both at the same time, actually. So that's a true emulation. It's a plug-and-play emulation. If you're, for example, replacing real 3490 tape drives, the ZVT is going to drop in and emulate the 3490 with minimal or no changes to your operating environment. Okay. The product is configured on a policy basis, so what we call a policy-based volume management approach. That allows you to assign attributes, parameters by volume in the GUI. It does have a graphical user interface that's web-based, but it's also controllable via the CLI or JCL interfaces. So anything that can be done functionally in the GUI can also be done via CLI or a JCL. It does, each node, each virtual tape engine has support for up to 32 virtual tape libraries. We also support up to 500,000 virtual volumes. Now that's actually a practical limit. We actually have a customer who is managing 500,000 virtual volumes. Theoretically, we can go to 2, 3, 4 times that with our database architecture. We've tested in our lab over 2 million virtual volumes with no problem, but our current largest customer is managing about 500,000 volumes. As a mainframe company and a mainframe heritage, we think data integrity is optimal. is of utmost importance. So we have integrated CRC checking into the design of the product to make sure that there's data integrity associated with the virtual tape appliance. We also, very importantly, we use a non-proprietary file format. So we use an AWS file format. We've had customers who were very adamant about having a non-proprietary file format, given that some of our competitors, the competitive offerings, do not have non-proprietary file formats. They actually have proprietary file formats. So some customers, it's not as important to. Others are it's a very important feature that that it is a file that can be accessed with or without the ZVT appliance. So that is what we do, a non-proprietary format. And then we also support LTO tape attachment. We have customers who have data sharing requirements, so you can attach a physical LTO tape drive to the ZVT appliance to do import-export of specific tape volumes for partner sharing, for example. And then we've made big investments with technology partners. So all of the leading storage management, tape management companies we have investments with and partnerships with. They have our product in their lab, we have theirs and ours, and we've integrated fully with them. So that includes tape management products from IBM, CEA, Innovation, CSI, et cetera, and of course DTS is a key partner of ours that we're going to highlight here a little bit. Okay, so in terms of product attributes, we created a legacy and a reputation over time, and these 5 tenets, what I'll call 5 tenets, have existed from the very beginning in our products and our approach to the marketplace for mainframe customers, and ZVT includes and involves all of these equally. Reliability is a very important factor to us. We're delivering ZVT on a 3rd generation hardware platform, so it's a platform that we're also using for our Prism solution. We're very familiar with the hardware and the support of that hardware, very stable. As I mentioned before, we're in the largest data centers in the world with our products. We're used to dealing with the demands of the large enterprise data centers, and we have that very cherished relationship with IBM System C, which is very important to us as well. Compatibility is very important. I mentioned the non-proprietary file format that we use. We have support for all operating systems on a plug-and-play basis. We emulate the key tape drive types 3490 and 3590, and we've invested in that testing and integration that I mentioned with all the leading tape backup providers. In terms of scalability and reliability, ZVT supports multi-node configuration, so we actually have multiple ZVTs that stay in sync with each other. If we were to lose or have a catastrophic issue, there's that level of availability that's built in the multi-node configuration. The dedupe replication encryption features are all supported, as I mentioned, and we can scale up to a full petabyte of storage in a single data cabinet. Okay. World-class service and support. I don't want to overstate this. Quality is important to us in our products, but certainly our products are not perfect. But if there is an anchor for Optica Technologies, it is the level of service and support that our customers have grown to be used to. So if there is an issue with the solution, it is really about our response and our professional attention to correcting the problem. And this is a very, very important factor to us, and it's something that we will always offer as a company. Then ultimately, it really is a satisfaction guarantee. Those just aren't words. If you're not completely satisfied with any one of our products, ZVT included, it can be returned for a full refund. To this point, we haven't had anybody take advantage of that offer, which is good. Okay, Whitney, if you don't mind, I'd like to pause here and actually put up the poll question if we can do that. Okay, there it is. Thank you. Hopefully everybody can see that. So here's the question. If you were preparing to invest in a new virtual tape solution, which single factor of the following 3 would be most likely to concern you or keep you up at night? So I ask you to consider that and select one of the 3, whether it's short-term, long-term impact to your operations and staff, or the migration. We hear that a lot, that migration is critical, obviously, and that's a big concern generally, migrating from your current environment to the new ZVT solution. or thirdly, essentially learning how to manage a new solution. There's going to be a new element in your data center. Your team needs to learn it. So which of those three, if you had to pick one, which of those three would concern you the most or cause you to lose a little bit of sleep? And so we'll give you a few seconds here to log your answer, and then I believe it'll actually show us some results in a little bit here. We'll actually show by percentage what the breakdown was. I imagine that all three of these are actually concerns on one level or another, and it'll be interesting to see what the audience thinks about that. So I'll just give it another couple seconds here, and maybe we'll have our results. Okay, the question disappeared, and here's our results. Okay, so interesting. So the vast majority, 65%, fingered the migration as the biggest concern, and I think that is actually consistent with the feedback we have received from our customers and prospects since we've been in the market. So that's what we would have guessed. Migration is a critical component whenever you're considering moving from one solution to another, especially when it involves the lifeline of your business, your data. And so that's consistent with what we would anticipate. Obviously, there's a concern around impact to the operations as well, and then followed in third place, managing a new solution. So I think the good news is for the balance of, I'm going to turn it over to Steve Pryor here after the next slide. But the good news is Steve is going to talk to you about the ZCC product that actually has an excellent solution for migration. It has a tool that addresses migration that adds a lot of value. So we'll look forward to talking about that. Okay, so before I turn it over to Steve, I did want to highlight our joint customer. We have one of our recent joint customers, that being a joint customer who invested in ZVT and the ZCC Control Center, or the ZVT Control Center from DTS. And this is just an overview of that customer and their experience. So this customer actually migrated from an Oracle VSM3 environment. So they were running VSM3, and they were actually shipping tapes off-site as part of their DR strategy. And they wanted to automate that process. They wanted to have virtual tape in both the DR site and production site. They wanted to be able to take advantage of replication between storage nodes and between locations to eliminate that physical removal of tapes in that step of their DR process. So this is a ZOS customer running CA management, tape management, CA1 in particular, suite of tape management products. And this particular customer is emulating both 3490 and 3590 with their ZVTs. And that's a direct replacement of what they were doing in the physical environment, given that there was a physical tape component behind the VSM3. So a few other details quickly. This customer had 64 virtual tape drives configured per node, using 16 concurrently. They decided to use 4 virtual tape drives for their migration, and they're managing 150,000 volumes in their environment. They have NFS. They invested in the iNAS solution, which comes with integrated NFS storage, as you can see here. And they're using about 50 terabytes raw storage per site. They did invest in the 10 gigabit interface for the connectivity to the storage. They're taking advantage of 3 out of the 4 what I'll call advanced features on the storage. Everything but the in-flight encryption they're taking advantage of. So in the interest of time, I'm going to turn it over to Steve, and Steve is actually going to be able to talk a little bit more about the value of ZCC and how that applied to this customer, but essentially they were very, very impressed with the ZCC migration utility in terms of the efficiency, the ability to stop and start, et cetera. So I'll let Steve expound on that. At this point, I'd like to turn it over to Steve Pryor.
Thanks, Sean. As Sean said, my name's Steve Pryor. I'm a developer here at DTS. And one of the products which I'm responsible for is the ZVT Control Center, or ZCC. And we've done a lot of collaborative work with Optica. We've worked. They've been great to work with. If we need something on the hardware side, we simply call them up and say, this is something we think that we could really use, or the customers could really use, or if they need something on the the software side, they'll call us up and say this would be a good feature to have, or what's your experience with this or that function. And so this collaboration led to the development of ZCC, and it's our software solution for the ZVT Control Center. There's any number of things that can be done with it, and of course the primary one, as evidenced by the poll we just took, the thing that people are always interested in is migration. I'm installing a new hardware system. How do I get there? How do I migrate the data on my existing system? And we have a couple of ways of doing that with ZCC. We'll talk a little bit about the volume cloning feature, which is really unique, and it's sort of a really interesting way of moving large amounts of data, and which is common with this sort of product. It's we're always moving 100 or 200,000 or up to as many as 1 million volumes in some data centers, depending on how large they are and how much tape they have to move. So since that's the thing that everybody is always interested in, we'll certainly talk about migration. There are a number of other components to the system. The primary one that is the other primary one that's besides migration that's also of interest is what we call allocation steering. That is, if you have a bunch of tape drives, a bunch of tape units in the system, and you're particularly during migration periods, but also if you have multiple different types of tape units in the system, which you'll certainly have during migration, you don't want to have to go and modify the JCL to direct tape allocations to one unit or another, and you want to make sure that when you're allocating a tape volume to when you're going to read a tape volume, that it gets allocated to the right type of device, that it gets allocated from a library in which the volume actually resides rather than somewhere where it can't be mounted. And so the allocation steering component of ZCC takes care of that sort of thing via a set of policy rules. We go and actually look at the libraries and ask the libraries, do you have this tape? If so, we'll mount it on an appropriate volume, regardless of what the JCL might say, whether it's SMS managed or non-SS managed. We have something called dynamic scratch synonyms, which both allocation steering and dynamic scratch synonyms, that is the ability to mount a tape from a particular scratch pool by policy rule. We used it the customer that Sean was just talking about. They had a number of different scratch pools and wanted to make sure that the new scratch allocations went to the right place, went to for the ZVT that was installed, that the jobs were pulling from the right scratch pool, and we could dynamically change the scratch synonym so that depending upon the job name or the the time of day or whatever other factor you might want, we can pull from the proper scratch pool. The ZCC has a lot of reporting facilities, and what we'll find is that the reporting facilities, reporting is sort of a boring subject, but it's the critical piece to migration. It's almost more important than actually how you migrate the data sets and the volumes is how do I know which volumes and which data sets to migrate and how far along in the migration am I? We have a number of other features. We want to be able to balance the allocation load, because now you have, perhaps with the ZVT, you have many more tape drives than you used to have, and you want to make sure that the allocation load is balanced across the back end. You want to make sure that you know what's going on in the back end, whether some of the back end volumes might be overused or underused. So we've got an activity monitoring feature there. But the thing that everybody's interested in is, of course, always migration. And the key to a successful migration, we have found, is how much planning you do ahead of time. The typical migration goes something along this, like this. If it's successful, they get the new technology in, they get the ZVT in, and once it's configured and configured and ready to go, we can begin directing scratch mounts over to that, and we can do that with the allocation steering facility that we have, so that existing tapes are pulled from the old technology, but the scratch mounts get directed to the ZVT. This can be done either via an SMS manual tape library, or we can even do it for non-SMS volumes through the allocation steering. So because the first thing we want to do when we're doing a migration is to migrate as little data as possible. The fastest migration is the migration that doesn't migrate any data. So we want to start moving all of our scratch mounts over to the ZVT first, and that's where the allocation steering component comes in. And in fact, that's again what this customer did before they actually began to migrate data, and they're still using it to direct the mounts of both scratch and non-scratch tapes. And so then when one installs DCC, it's sort of a typical vendor product install. There's a started task, which we call diff for the dynamic install facility. It requires, of course, an APF authorized library, because we're doing system-oriented things like controlling the mounting of scratch tapes, or controlling the selection of tape drives and tape libraries. And that started task depends upon two ParmLib members, or two text members that define to us what the ZVT looks like, the ZV2 pools member, and how I want to allocate tape drives. That is where I want to, if I'm doing allocation steering, or if I'm dynamically changing the scratch pool, then I have a policy rule member called ZVT rules, and that's those two very simple text PDS members allow us to manage the ZVT and manage the allocation. But if we're going to do a migration, we have to keep track of what's going on. And so there's an audit file, which is a VSAM file, that gets defined and is used by ZVT Control Center to keep track of which volumes have I migrated. How far along in the migration am I? How many volumes do I have to go? How many terabytes have I migrated so far? So the audit file is sort of a critical resource, because it really tells us how much further we've got to go in the migration. We'll talk about the dummy volumes that get defined. If we're going to if the output, the ZVT, particularly if the ZVT is, oops, I'm sorry, I just went ahead a slide. If the ZVT is SMS managed, we define some dummy volumes in the tape configuration database in SMS to allow us to use that we use as a model for copying volumes over. But the most important thing is to prepare the migration volume lists, because in order for ZVT Control Center to do any migration, we have to know which volumes to migrate. And so we have a rather extensive reporting facility that allows us to generate those volume lists. And then finally, once those volume lists are generated, we run our what we call the ZVT clone utility to copy on the volume level, or the ZVT copy utility if we want to copy things at the dataset level. So in terms of migration planning, which is really the most important part of the migration, we depend upon a reporting utility, the ZCC reporting utility, which goes and looks at several different sources of information to determine what sort of environment it's running in. How many volumes do I have to migrate, and how many terabytes do I have to migrate? Because we need to look, and primarily we look at the tape management system, because the tape management system knows where all of the tapes are. And so we look at the tape management system, and we also look at the source library, because if it's coming from an EMC DLM or from an IBM TS7700 or any sort of automated virtual tape system, those virtual tape systems will have reports, the virtual tape volume report, a multi-volume cartridge report. For the IBM systems, it's called BVIR, the bulk volume information retrieval. They have something that tells us which logical volumes reside on the physical cartridges, because we want to be able to order the volumes as we mount them in the order they appear, or in the order they appear on the physical cartridge, so that we aren't constantly flooding the cache with new requests, flooding the source cache with new requests for volumes. We want to mount all of the volumes that reside on a single physical volume. We'd like to process those together. And so the ZCC reporting utility takes in information from the tape management system and optionally information from the source library, the actual physical inventory of the device, the reports that are generated from that library, the BVIR reports, and then we filter them, because we don't want to copy every volume. There are certain volumes we don't want to copy. We don't want to copy volumes that are about to reach their expiration date. And it's important to note there which expiration date we're talking about. If the volumes are retained by, for example, RMM vital record specifications, we want to look at the retention date, the vital record retention date, rather than the expiration date. But we don't want to make sure we don't copy volumes that are about to expire. We want to make sure we don't copy volumes that are in scratch status or that are about to go scratch. We perhaps want to take other volumes that are that we may want to use other migration tools for, perhaps HSM. Although ZCC can certainly migrate HSM volumes, some installations prefer to migrate those separately and do a consolidation at the same time. One of the nice things about ZVT, as we'll the ZVT Control Center, as we'll see, is that we can migrate almost any type of volume regardless of what the metadata might be. So ultimately what we get out of the ZCC report utility is several lists of logical volumes. We want to, as we said, take into account the fact that the logical volumes may themselves reside in the source device on a set of physical volumes, and so we want to sort them by physical volume, and we come up with several different lists. We come up with a list of single volume data, or single volume tapes. That is, tapes that begin and end. They may have multiple files on them, but everything begins and ends on the same volume. And this is, in fact, in most installations, the majority of the tapes. We also want to have a separate set of a separate list of tapes for multi-volume tapes, because we want to probably copy those together. We don't want to have part of a multi-volume tape in the source library and part in the target library. And we have perhaps some exclusion lists, things that we don't want to copy, and as we said, those are volumes that are about to expire or that for some reason we don't want to copy because we want to use some other utility. But once we have our list of volumes, and this is the primary success factor in migration, is having a robust reporting utility like ZCC to generate these lists of volumes, then we have to go and copy the volumes. And this is where our cloning methodology comes in. We were really I think the first vendor to come up with this. The idea is that we have a couple of, wherever the source is coming from, we have a list of input volumes that we have generated out of our report utility. And they are that list is input into a program called ZVT Clone. ZVT Clone has a bunch of output data sets or output DDs that allocate the target tape drives in the ZVT. And so we'll multitask this anywhere from 1 to, well, theoretically 99 output volumes. The bottleneck tends to be, of course, on the input side because that's usually the slower device. But we'll multitask perhaps as many as 14 or 15 or 20 volume copies at the same time, and we don't copy the individual data sets with ZVT Clone. We copy volumes at a time. We copy entire volumes byte for byte. And what this allows us to do is to not worry about the individual data set records in the tape management system, or not worry about the Mobius metadata, for example, or any other application's metadata that keeps track of its own data sets and keeps track of its own volumes. We really don't have to worry about, because the cloning process copies the volume from input to output byte for byte and retains the same volume serial number. So really the only thing that we have to update is on the volume level. ZVT Clone, when it finishes copying a volume, will update the tape management system volume entry, with the new location and perhaps the new storage group for the data set, the new library location. It'll indicate it's in the ZVT rather than in the, the storage tag VSM or wherever it came from. So we have one update per volume to the tape management system, and if it's an SMS managed tape, one update per volume to the TCDB, to the Volcat entry, again, to indicate the new library location. So it's a very efficient way of copying large numbers of volumes without having to go and do a lot of metadata updates. And so this is sort of a migration overview. I want to talk a little bit more about exactly how this migration works at the volume level, and then show you a very quick example. So so the way that volume cloning works is we have some dummy volumes, as we saw in the previous slide. We have some dummy volume serial numbers that are allocated or that are defined in the tape configuration database, defined in the Volcat as belonging to the ZVT. So what we do is take our input volume list that we generated from our reports. We take our input volume list, and for every volume in that input volume list, the very first thing we do is to add it to the audit file. The audit file, again, is a critical resource because it tells us, have I done these volumes yet? And so we validate, at that point, we start reading the audit file back and say, okay, it's time to mount an input volume. We'll validate that it still exists in the source device. We'll mount it, and then we'll attach a subtask, in which the out DD, the output data set, or the output DD, points to a dummy volume. And this is a sort of a unique technology that I don't believe any other vendor uses. We actually issue an initialize command for that dummy volume. The dummy volume doesn't actually exist in the ZVT until we initialize it. We issue an initialize command, which takes place more or less instantaneously, and then we can copy the entire volume, including the tape label, byte for byte from the input. So what we have is an exact copy of the input volume, including the volume label, including the volume serial number. So we then go and update any of the metadata that's required, and there's usually only two metadata updates required, one for the TCDB and one for the tape management system. And actually, I should mention there is a third, of course. We update the audit file to indicate the volume is done. And then finally, we write the completion messages. We can deallocate the drive, and then we start with the next volume on that. We don't actually deallocate the drives till the end, but we start with the next volume so that we keep reinitializing the same dummy volume into the ZVT and then copying the data over it. So there's no need to have any scratch volumes pre-allocated in the ZVT. We simply copy it volume for volume. And so let me give you a very quick example of that. Let me log onto this system very quickly. And I'll go to my ZVT clone job. And as you can see, it's a very simple job. The program name is ZVT clone. We tell it where the input is. It's from the input is to be mounted on a 3490 device. So unit 3490 will allocate our input device dynamically, and we take there's some output parameters here that I use because of I haven't my tape management system is RMM, and I want to update on the RMM update the RMM volume records. I have a pointer to my audit data set, and I have an output out1 DD that points to a non-existent volume in the ZVT. In this case, my non-existent volume is called SMSTP4. Code expiration date 98,000 because I don't really want this. I don't want this dummy volume, this SMSTP4 volume, to exist in RMM. And then I have simply a list of volumes to copy. In this case, I just have one volume in my list. But we can go and copy this volume. Just by. And this, I might in fact here have perhaps 20 or 30 or 40 or 50,000 volumes in the list. But I will go ahead and submit this job. And that volume serial number now goes into the audit file. And if we go and look at the job, we can see we got a mount for the input volume, mount private on the unit 6333, which is my input called, which is actually a ZVT itself. I'm actually copying from one ZVT here to another, copying from what I call library 3 to library 4. And so we can see we have a mount for the volume 6333. And let me see what else happened here. Oops, I'm sorry, that was the generate. Choose the correct job. Let's see. Okay, well, I was copying this job, and of course, this is what happens when you do a live demo. We make sure that everything's online. And we can see that ZVT Control Center is up and running. I'm not sure I'm not sure why why we're not getting them out for that volume. So let me just run it with a different volume. This always happens, of course, when you do it without a net. And there we go. Okay, so this is an experimental system, so I sometimes have volumes that are in very strange statuses. So here we actually copy the volume. I have a mount for the 6300 range for volume ZM0026, so that's my input volume. And now I have a mount for the 6400 range for my ZVT library 4. I'm copying again from library 3 to 4 for my dummy volume. I get a mount for the dummy volume. We initialize the dummy volume, and then we have a keep for the input volume and a keep for the output volume. And then we can see some messages from RMM indicating that the TCDB was updated and the RMM records were updated into library 4. And so if we now go and look at our output for sysprint, we can see we copied one volume with DD name about 1. There wasn't much on it. It was just 4 blocks from library 3 to library 4. And so that's all there is, really, to copying this, and it will copy any number of volumes. And so we can stop it at any point. We can issue a stop command if we want it to stop at some particular point in time. We can have multitask this to as many as 99 separate DDs, out 1, out 2, out 3, and so on. And we can, but once we've done that clone, we want to make sure that in fact it was added to the audit file. So the audit file at the end of this job, the volume is added to the audit file. And the audit file, which is accessible, it's a multitasking audit file. It's a VSAM file. We allow multiple access to it. And so it provides the ability to restart the job if something fails. It provides all the error logging, and it gives us a lot of statistics in terms of CPU time and so on. So we can see that these volumes were done. These volumes, when we encountered them, were in scratch status because some volumes may have gone into scratch status between the time we generated the input volume list and the time we have the copy. Now, this volume is currently being copied. When that copy is done, the report, the DLM clone will update the audit file. We can also do copying by dataset. We're a little short on time, so I won't go into the dataset level copy in great detail. But it's very similar. We can just specify a group of data sets, and we can specify volumes, and we'll copy all of the volumes in the chain. Now, in this case, we actually have to do updates on the volume level and on the data set level, and so we actually copy to a new volume. So if I look at ZVT copy, just to show you the JCL, we won't actually run it. This is ZVT copy. In this case, the output DD actually allocates me an output drive, and so I'm going to copy whatever volumes I specify here. This will copy all of the volumes on the data set and update them individually. And this is useful where we can't do cloning. If for some reason we need to copy from a 3490 to to a 3590, that has to be done at the dataset level because cloning, of course, requires that the volume architecture be the same. In most installations, every volume is copied by cloning, but you can do a dataset level copy if you want, which does allow us to do things like rename or stack the volumes on the copy. Okay. We mentioned allocation steering. This is something that we just had a customer use quite recently, as Sean said, and they were needed to copy a number of their volumes and needed to make sure that they went to the right scratch pool, or the new allocations, new scratch tapes went to the right scratch pool. So we get control as part of ZOS allocation processing, and we have, as we said, the pool definitions, which define what all of the tape drives in the system look like, and the policy rules that will allow us to query the ZVT inventory and say, for an existing tape, do you have the tape? Fine, I'll allocate to you. Or if you don't have the tape, I'll allocate to someone else. Or if it's a scratch tape, to set the scratch synonym so that the scratch tape is mounted from the proper pools. This is just an example of what the ZVT allocation steering rules look like. They're very simple. It's very simple if-then-else language in which I can say set tape pool equals, and that by virtue of saying set tape pool equals tape live 1, that will select whatever devices are defined to tape live 1. If I have, for example, a tape data set beginning with a count name of prod or pay or GCC, then it goes to, it will mount from the scratch pool called prod pool. And if the RACF user is T or D or something, then it will mount a scratch tape from the tapes scratch pool test pool. So we can get very sophisticated in these if we want, but usually the allocation rules are quite simple. I want to, based on the dataset name or based on the job name, select a particular group of devices or select a particular scratch pool. Finally, we can do some activity log monitoring. We can keep track. Again, we have a batch job that runs a set of policy rules, looks at what's happening in the ZVT activity log, and we can run a set of policy rules against it to say, well, if an interesting message has appeared in the ZVT activity log, then I can go and send an email to users with the contents of it, perhaps run some recs execs, write report records. We can monitor at any time what's going on the back end. There's also an ISPF interface, which I'll just show you very briefly, to the ZVT, where we can show the ZVT libraries. We can look at the results of the audits. I can go and, if I wanted to look at ZVT library 3 here, for example, and I wanted to look at the current file system usage on ZVT library 3, it tells me what file systems exist there and what their utilization is and so on. I can also look directly at the activity log. So there's lots of additional things that ZCC can do besides just migration, although of course migration is the thing that everybody wants to know about. But migration depends upon reporting, and we do have a fairly robust reporting utility that will take information from several different sources and combine it, filter it, and produce the output that's interesting, which is either the volume selection lists or a report on how far along we are in the audit file, or reports on what the storage utilization is at the back end, and so on. And so there are a number of other features which I think we're probably very short on time, so I won't go into in detail, but we have TSO commands, an ISPF interface, and a batch interface to all of this. There is a high availability option for the allocation steering component to make sure that in the event of a failure, if you have a second ZVT, we can fail over to those more or less automatically. And I think at this point, I'll turn it back over to you, Sean.
Okay, thank you, Steve. I appreciate that. We are at the top of the hour here, so Whitney, I think our strategy will be to answer any questions. We'll document those and send them out to the group after the fact here, since we're out of time. Is that correct?
Yes, that is correct. So that does conclude today's webcast, and I just want to thank everybody, especially Sean, Steve, and the Optica Technologies team for attending the event today. So you know, attendees, this feature will soon be available on the SHARE website at www.share.org. And if we didn't get to your question, we will post the questions with answers on share.org along with the recording and the slides. There's a survey after this webinar for you to complete, and we thank you in advance for your feedback. Thanks again, everyone, for attending today, and have a great day.